Good day, everyone. Good morning. Coming to you live from San Francisco at 9 a.m. Pacific Standard. My name is Patricia Dugan. I am the head of community for Traefik. And today we have an online meetup for you. And we're super excited to bring your way. Thank you very much for taking the time to join us on this special occasion. Traefik online meetups. We showcase ways Traefik is being used to solve interesting technical challenges by companies and developers. That's what you'll always find when you join us. They're demo rich and have very cool people presenting and cool companies. So thank you for joining us for this, and we hope you'll join us for future ones. A little bit I'd like you to know, we have something going on called the Traefik Ambassador Program. And if you're interested, you can become a Traefik ambassador by contributing code, contributing content, or creating a Traefik community in your local area or via online meetups. If you're interested, please get in touch with us. Go to the Kubernetes Traefik ambassador page and fill out the information, or you may reach me on Twitter or us on Twitter, and we're happy to answer any questions for you. Also, we are hiring. We have a ton of roles coming out right now, so please check out Kubernetes, the /careers, and join us for more upcoming events, online meetups, which would be Kubernetes /events, and we have about 5 coming up. We have WP Engine, Stack Rocks. We're going to have Alex from OpenFast, which we're all stoked on. What else? Alejandra Betancourt of Gonkar IT. So we hope you can join us for that. If you cannot, please sign up to our YouTube channel, subscribe, and then you'll be notified when we upload the videos. So with that, today we have an online meetup with Dr. Rion Dooley called 5 Ways to Level Up Your Developer Powers with Traefik. Dr. Rion Dooley is the Director of Platform Services and Solutions at Data Machines Corporation. He came to DMC from Texas Advanced Computing Center, where he spent the last decade integrating new and emerging technologies to build solutions that make it easier to conduct open digital science. He is an absolute baller, as we say. He's super cool. He is chill. So we are excited to share his personality and expertise with you. And I'm going to go ahead and share his GitHub with some of the information from our presentation today in the chat box. Also, if you have any questions, please enter them in the chat box. We will answer them towards the end of the session. And I think that's all. What you need to know about reaching me is my Twitter handle is Patricia Dugan. The best Twitter is at Traefik and then #Traefik. And I look forward to getting to know you. And with that, Rion, we're going to pass it over to you and watch your show. Thank you.
Great. Well, thank you, Patricia. As you said, I'm Rion Dooley. I'm work over at Data Machines, Director of Platform Services and Solutions. Today, I want to share some of the stuff that I've done with Traefik over the last couple of years throughout a handful of different projects. Traffic's one of my favorite technologies. It's kind of my reverse proxy of choice for pretty much everything that we do. As we've kind of grown from working in doing a lot of native code development to working in a container environment and single host to moving over to Swarm and now in Kubernetes. So it's been a good tool that we've grown with, and there's a lot of cool stuff that I think it would behoove the community to hear about. So I'm going to share some of those things with you today. I'm not speaking from an official position. I'm not really making any recommendations about what you should be doing with it, or how I think the tool should to change, or feature requests I have for it. I'm just going to share some of the things that we've done with it. So I think Patricia is posting the link in the link to the GitHub repo that has all of these examples in it. Has the markdown documents that I'm going to be running through as we talk, so you guys can follow along at home. If you have any questions, feel free to hit me up on Twitter, @Dooley, or email me directly. You can find my contact information on the Data Machines page. Okay, so let's kick this off. Traefik is very cool. It has been my go-to for quite some time. I'm going to go ahead and throw my screen up here so you guys can track what's going on. Okay. All right, so we are going to start out talking about how to level up your developer powers of Traefik, right? So 5 different ways. We're going to talk about using Traefik for local API management. Traefik is not an API manager. It's not meant to do that. There's some stark differences between it and the API manager space, but it does serve as a really good skeleton for one, right? It gives you kind of the basic things that you need to work in a hybrid environment, and we're going to walk through how I do that. We're going to look at the dynamic load balancing capabilities that Traefik has, both locally and in a swarm, and you can use that to do some cool things. How you can protect your applications with an auth firewall. Traefik doesn't have identity access management baked in, but it does really have a good mechanism for incorporating that into its normal proxying flow. And then we're going to move on to talking about Ingress controllers and how you can use Traefik and Kubernetes to give you some isolation and smooth your developer operations and make it a little bit easier to onboard people with good CI/CD as they're developing. And then lastly, hopefully we'll have enough time, we'll just touch on using Traefik for basic uptime monitoring and some health checks in Kubernetes and elsewhere. Okay, so local API management. So I personally tend to work in a hybrid environment where a lot of services run in the cloud. There's always something running locally, and I'm constantly developing something else, right? So we have these development workflows that tend to be very tightly ingrained with a lot of other support services. I can't really fit all of those on a single host anymore. So as these things sprawl out, I need a mechanism for working in this hybrid environment. And one of the challenges, anyone that does a lot of application development, especially as you build out these larger distributed systems, is you don't want to have to start juggling configurations. You don't want to have to start juggling your DNS and service discovery and piecing that together, especially when you're doing development in languages that are strongly typed, that you're compiling a lot, right? I do a lot of Java development still. Also write in Go and TypeScript. So I'm constantly compiling stuff. And when you're offloading all your compiling to an entire build cycle inside of a container, pushing it up somewhere, redeploying it, waiting for the deployment to roll out, and then you can actually start working against it. That's an incredible slowdown in your productivity, right? So I tend to do a lot of the iterative kind of short daily sprints out of my IDE. Let it do the in-place compiling, right? So it's just doing byte level replacement. And then I will use Traefik to proxy those services into an overloaded, overriding DNS locally, and using Traefik to proxy out all the support services that I would normally be hitting to their existing deployments in the cloud, right? So everything that's static that I need to use, I'm actually just communicating with Traefik and letting it proxy everything out there. And that's worked out pretty well for me, right? A couple tricks that I find helpful are using Gas Mask. If you haven't heard of that, Gas Mask is a tool for OS X that lets you juggle Etsy host files. So I can go ahead and have 4 or 5 different Etsy host files for, containing hostname overrides for whatever project I'm working on, right? Just activate those, and I leave an instance of Traefik running pretty much all the time, right? So I'll use I'll use a directory where I'll just throw static files that Traefik is constantly watching and reloading on, and those are always pointing to things that I have running locally. So an example would be, let's see, so dashboard dot dashboard dot local. Yes, I did mean to go to that. So I put this in one of my Etzios files, and it's going to redirect everything to the Kubernetes dashboard that's running on Minikube, right? I just leave that up and running. That's a local entry in my Etsy host, and I never have to change that. I also never have to remember the really, really long URLs, right? And if I need to add in multiple other versions, I can do that really easy, just with a couple lines of YAML in the local config file. In addition to that, I will do fun stuff like listen to the Docker daemon on localhost, right? And I will have Traefik filter out containers that have a specific label on them and automatically publish those into my local space, right? An example of that, let's see, so we're talking about local API management here. By the way, this is the Traefik config that I have. I usually use the static command line options to launch it, and then we'll have the static config folder that it's listening to. Right here's the config that's pointing to Minikube, the Kubernetes dashboard running on Minikube, and then say I have some other services out there, like here's Nginx, HTTP bin, and this Who Am I service that is an example through. That we'll use as the web server through a handful of these other examples that I'm going to call thing one here. All right, so I already have, let's see, I have Traefik running here locally. Let's see, GC up. Yep, so Traefik's already running locally. We can see that it's running by just coming in here and clicking on the dashboard. Right, so I can see all the routes that I have published in here. You see this is the Kubernetes dashboard. But I have this listener on the Docker daemon. This is running in a completely separate compose file, separate namespace. I use a global network that I can just have my other containers attached to when I'm launching them. And that allows me to spin these things up and have them automatically publish. Right, so let's go into services. We'll launch those, and we can come back here and we'll see those pick up. Right, so now we have the HTTP bin and thing one both showing up here. Why are there two here and not three? Well, it's because we were using this filter in our Traefik instance. We were saying that we only want containers that have this label, this local proxy enabled, which is just arbitrary. It's just what I use. You can use whatever you need. But I use this label just so I don't accidentally add every container that's launched on my host into this Traefik instance. And that works out pretty well, right? It's an easy way to start and stop and not have to run a whole bunch of instances to do what you need to. Okay, so local API management. That's it for that. Let's talk about some of the load balancing features, right? Because Traefik is really, really cool about listening and automatically reacting to things. I'm going to switch over to this other folder, Dynamic Load Balancer. Okay, in this folder, we're gonna, should go into the compose folder, huh? Okay. In this folder, I'm gonna spin up another stack. This is a Traefik instance, different from the one that I was running before. This is just listening to the Docker socket, right? And it's running on port 80 and 443, and we also have a gRPC endpoint in here because we can load balance across those as well. Down here, I have an instance of this thing one service, right? So if I go in and I look at the dashboard here, we're going to see thing one is listed. You see the service that's running. This is the internal IP of the container that Docker Compose spun up. And Traefik automatically just listened to the Docker daemon, queried the local Docker API, got a list of the services that were running parcel labels, and it found this one, right? It spun it up. The cool thing is it's going to keep listening. Right? So if I need to spin up additional instances of this thing one container, I can do that. You see, I'm going to scale this up to, we'll say 6, right? So I'm going to scale from 1 to 6 containers, right? Traefik is automatically going to pick that up, right? Update its internal config, and now it's going to be load balancing, not against just one, but against all 6 of those, right? Just round robining the entire time. That's pretty cool. If we scale down, or if they die for whatever reason, I'm going to scale this down to 0. Traefik is going to catch that, and it'll actually remove the service, right? So the route won't even be there anymore. That's really handy. It means you can add stuff and scale it up. You can withstand, fault tolerant activities. You can, rolling deployments, circuit breaker, all kinds of things, and Traefik's just going to respond appropriately, right? So it's got your back, right? It's listening to the state of the entire system and handling it appropriately. When you're working locally, you may or may not have a situation where you need to scale up a whole bunch of services or replicas of a service just to run on your laptop. But when you're running out in a distributed environment, that becomes more important, right? So moving from Docker to Swarm when you're using Traefik is really trivial, right? It's a single line change in your config. There's not a whole lot that you really need to think about. I'm lead developer on another project called the Agave Platform. Go to agaveplatform.org. It's linked in the repo that we're using today. But the Agave Platform is a science as a service platform that we use to help scientists do their science better, right? It moves data, runs your code, helps you collaborate meaningfully, and lets you integrate with pretty much everything. There's a lot to the platform. So we do these trainings pretty regularly, usually 3-4 times a year. We'll do these in-person trainings. We'll have anywhere from 30 to 200 people that we're walking through these kind of 101 and 201 level classes, helping them understand how to use the platform, how to apply it to their science. Well, in order to make use of the time we have available in these training sessions, we spin up an entire lab environment for them. And we were running into a lot of problems where people were forgetting URLs. They were not remembering kind of these random names and IDs that we were using to namespace the different environments we set up. And we would sometimes have more people show up than we had already provisioned environments for. So we switched from what we were doing before, which was largely just a static predefined environment where we had people pre-register, to a completely dynamic environment where we just scaled out the number of hosts to support whoever showed up that day in pretty much real time, right? And we wanted to get around the use of nonces that no one could remember, and instead switch to something that was much more useful, right? And potentially get a single sign-on in place. So we did that, and the key to all of that was really using Traefik, right? Because Traefik allowed us to go from having to really hard code and parameterize our entire deployment to saying, no, we're just going to deploy stuff out on Swarm, and we're not going to think about it anymore. Right. So here's an example of a cluster. One of our labs that I spun up. It's just it's a 5-node Swarm, right? With management running on a couple, and then 3 training nodes here. The training nodes represent users. So we have training node 001 for training user, training 001, training 002, and 003, right? So each of these have a couple stacks of services that we deploy. right, based on the username. And that gets picked up by Swarm, published out over, and made available to as events that Traefik can listen to. Traefik picks up on those, automatically provisions the correct load balancers for the services that we've exposed, right? And we configured Traefik to handle SNI termination for the entire stack as well. So when we spin up one of these new training clusters, we get for free a new vanity domain for that user, right? With a valid Let's Encrypt certificate pulled for that subdomain. So training 001 has a top level trusted domain name just for them, right? That's dynamically provisioned and will always be there, automatically pointing to all their backend services. We tend to run a handful of different services for them. Sometimes they start eating up a lot of resources, so we'll move them to other hosts where they'll automatically get rescheduled. Traefik automatically picks that up for us. We don't have to do anything. We don't have to think about it. It just is working, which is pretty cool, right? So it gives you a lot of functionality that you kind of take for granted now in Kubernetes, but in an environment where you absolutely don't have those kind of capabilities available to you out of the box, right? So we've been able to get some mileage out of that. And the dynamic load balancing that we saw when we were running Docker Compose and scaling up and down, having things just picked up, it works exactly the same way within this swarm, right? So no need to really worry about that. The difference is that Swarm is listening to, that Traefik is listening to the Swarm daemon, querying the Swarm API rather than querying just the querying the single Docker engine for a list of containers. It's instead tapping into the load balancing of Swarm itself. So the difference here, and this UI looks a little different because this is running the 1.7 release of Traefik, whereas locally we're running the 2.0. Same thing is happening though. Right? You can see in here we have this thing1 service, just like we had before, right? And we know that if we look here, we'll find thing1 running. It currently has 1 replica. We can scale that up to 6 like we had before. That's going to scale it out. All these are going to start here in just a moment. And then when we go back and we look at the Traefik dashboard, we'll see Traefik still showing 1 server. Why is that? Because it's hitting the load balance endpoint for that service, right? It's using Swarm's kind of built-in overlay network and just hitting the load balance endpoint instead of trying to manage all of them independently. So it's pretty cool. Adapts to the environment, picks up the way you want it to pick up, and just kind of works. So yes, dynamic load balancing. That is a super, super cool feature. One of the things that I did want to mention, recently, let's see, Traefik released their second major release. So V2 is out now. I think we're at 2.13, something like that. They do give you a lot of tooling when you're trying to upgrade and move from 1 to 2. We did a lot of kind of crazy stuff with V1. All right, so we didn't necessarily just have happy path configs. We were doing a bunch of header manipulation. Most of what we do is dynamic configuration, so we're taking advantage of a lot of the dynamic discovery that Traefik is doing, and we do that by leveraging labels inside of our containers. Right, so moving from V1 to V2, all of the labels changed. There was a breaking change for the syntax for the TOML files, and they also now support YAML. So we're slowly migrating all of the Traefik configs we had from V1 to V2, but we did run into some gotchas, right? So the migration tool that they provide, Traefik migration tool, it's in Docker Hub, you can download the binary. you can find it in their GitHub repo, is really cool and it helps out a lot. But it's only going to get you probably about 80% of the way there, right? If you're using purely static configs, it's not going to get you the entire way. There's some things that it won't pick up, like the Acme configs. If you're using Let's Encrypt to pull SSL certs like we showed in this form, those aren't going to get migrated. So you're going to have to do those by hand. You know, it's only 5 or 6 lines of YAML, but it's just something to know about, because if you're running a lot of different instances of traffic, that's just a bunch of configs that you need to update. And that's true with the whether you're using the TOML files or you're using the command line arguments. There's going to be some dirty work that you're going to have to do. The migration of your labels that you're currently using, there isn't a tool to do that, right? So if everything you're doing is dynamic and you're just really counting on those labels to configure everything for you, then you're manually going to have to go in by hand and update all of those. Now, I will say that after you do, half a dozen of those, it becomes pretty tedious. So, you can write a script to migrate those yourself, or at least do a happy path to knock out the vast majority of them, just regexing and sagging across files. But that nevertheless is something you're going to have to do. And the other part about that is that you can't just upgrade traffic in place. So, bounce your container and come back up with V2, because it's not going to support the previous labels, right? So you're going to have some downtime as you make that conversion. You can do a rolling deployment, and that's fine, right? But even when you do that, traffic is going to restart in a matter of milliseconds. But the application that you're running and you're proxying with traffic may not bounce back quite so quickly. So you do need to prep and plan for some downtime around that. All in all, it's not that bad though. It's kind of alarming to look at it first, but you get the hang of it really, really quickly. And the additional functionality they added is totally worth it. So there's our experience. Another use case. Let's move on to 3. So protecting apps with an auth gateway. If you've been around developing for a while, at some point you've had to bootstrap identity and access management into your application, right? At the very least, you've had to figure out how to log someone in. But if you've been working with other people's code for very long, you probably have found yourself in a situation where you've got to figure out a way to protect an application that you just can't change, right? So how do you do that, right? Well, there's a lot of ways, right? If you were 10 years ago, you'd say, well, we're just going to use Apache and mod proxy to front this, or maybe we'll do it with Nginx. Maybe you would throw something at the firewall or the router to just block all traffic, outside of some otherwise identified people, right? So limit it to VPN, or limit it to an IP white range or something like that. Whatever approach you were taking, it's always a pain, right? But Traefik is pretty cool in that it allows you to do most of those things. And it gives you some interesting options with some of the more familiar ways that we're authenticating applications today. So one of the things that we've been doing recently for some customers at Data Machines is providing OIDC logins to existing legacy apps, right? So someone needs to ship an application. It's got to be restricted to a handful of people. They may not have, they may want to restrict who can actually see that for whatever reason. But they can't actually change the code of the application they want to protect, right? So you just need to put something in front of it to lock it down. You can do that with Traefik pretty easily, right? So there's an auth forwarder middleware in V2 that you can use. Similar concept was there in V1 as well. And so what we do is we leverage that auth redirect feature of Traefik to send all the traffic coming into any of the pretty much any endpoint that Traefik is proxying, and we redirect to an authorization app that a user has to log in to a DEX server. If you're not familiar with DEX, DEX is a really cool OIDC implementation. It supports Federation. It was written by CoreOS. It's really popular when you want to add auth login to Kubernetes. We use it in a lot of situations. We're using Kubernetes. We use it out of Kubernetes a bunch of places, right? It's super, super versatile, and it gives you a clean way to federate logins across a lot of different identity providers. But so we just run, we stand up a stack with a DEX server, with a forwarder, and configure Traefik to use that as an interceptor. And what it does is gives you an authenticated firewall in front of your application just out of the box. We have an example of that here in this repo in the auth gateway folder. Let me shut down the old one, our last example. And what I'm doing here is I'm just going to spin up this Traefik server. This is running the 1.7 release. It's still cool. Still works fine. Still, there's a couple things in the V2 that are tripping up the callback. So I'm still working on getting that ported over. But nevertheless, right? This is what we have going on, right? So 2 services running. We're not exposing the ports to the outside world. The only thing that can see them is Traefik, right? So we've got kind of a couple layers of protection there. We have this Traefik forward auth container that's running that just does exactly what it says, right? It just forwards the auth over to DEX, comes back, writes a cookie, the domain, the cookie name, information in there is all configurable. But it does that and then forwards the Traefik back, no pun intended, forwards the request back to Traefik, which will then send it off to the original destination. So, and then finally we have our DEX server running here. So what's that look like in practice? It probably about what you think it'd look like. So if we go to thing 2, right? It's going to intercept the request, send it over to the DEX server. I can log in with a super secret password here, which is example.com and password, and boom, sends me back to thing 2. Now, as long as I'm already authenticated, session's there, and now it's just business as usual, right? So I'm just interacting with the service directly at this point. If I went over to the other container that we had running in there, the thing 1. Thing 1 is going to redirect me to the login page again. And the reason it's going to do that is because they're running on separate domains, right? Here we have the cookie domain writing to localhost.com, right? So they don't have a shared domain that they're using, which is why it's forcing another authentication. But I can auth here just like I did before, and now you got independent protection for each of my applications. If I started another one, that would get protected too, exact same way. So this is a handy way just to throw up basic auth in front of the services that you care about, right? You can always whitelist and put exceptions in there, so that you can say, you know, anyone can. I want this endpoint or this service to be exposed to the outside world cleanly, and everything else to be authenticated. You can lock it down to communication. Clear in the open between services, but authenticated to the outside world. It gives you, a lot of flexibility you'd want from kind of a more robust auth implementation, but it's really lightweight and it just kind of works, right? Speaks to the flexibility that you have with Traefik. So that's cool. We use that, but we're not always just working in Docker Compose or Swarm, right? The industry's kind of moved to Kubernetes now. So what we've been doing lately is moving over to use leverage Ingress, Kubernetes Ingress in a more useful way, right? So Traefik also functions as an ingress controller. We have a Helm chart to deploy it out into our Minikube instance, which is what we've done here. A normal Helm install will do the trick for you. And you can find all these instructions in the repo now. Just go ahead and check it out. What we're doing on some of our projects is helping to onboard developers a little bit easier. So we have a larger system, right, that a lot of people are working on different components on at any given time. So we don't want a shared development environment because of the breaking changes involved in that. So just out of the box, everyone gets their own development environment, right? They're isolated with the namespace within Kubernetes. And then we set up an ingress rule that's doing pretty much the same thing that we were doing with our Swarm demo earlier, right? So we have the Traefik ingress, which is defaulting back to cert manager to pull the Let's Encrypt cert for a subdomain named after the developer's ID, right? So I'm Dooley, right? So there's a subdomain here for Dooley that's that lines up with the namespace in Kubernetes, right? So anytime I'm committing anything, it goes to my default namespace, right? It's going to deploy out to my default namespace, Dooley, in our Kubernetes cluster. That's going to have an ingress route associated with it that has a Dooley subdomain with a valid top-level cert there. So I can now go and test against whatever I need to. I can use the local Traefik config to override some of those routes when I need to do part of my development locally, and leave the rest of the services running out there. Or I can just do everything out in the cloud. But when we onboard another developer, as long as they have their own username, then everything is just kind of magically working, right? They have their own namespace, their own isolated development environment. Everything just kind of works cleanly. And then when it's time to merge our changes and put together a release candidate, right? Our dev branch has its own namespace, its own subdomain. Same thing with staging, QA, and prod. Right? So it's a really clean way for us to keep all this stuff straight, to onboard new people, let people do whatever they think is right in their namespace without impacting anybody else. And we still retain all of the same merge strategies that we had working with Git, right? We can still use Git flow. We can still use the standard tooling that we like to use with Jib and Helm and Ansible and a handful of other things. But Traefik just saves us a lot of trouble there. Now, Traefik isn't the only ingress controller out there. There's a lot of them, right? And ingress is kind of a fundamental resource in Kubernetes. It's not on by default, but it is part of the base specification. So it's just part of the API. So all of these ingress controllers that you're going to run across are going to implement the same basic things, right? Traefik does uses custom resources to extend the functionality of ingress, right? To add value add over and above what it would otherwise do. So you don't need to run cert manager within your cluster. You can just run, you can have Traefik handle all that itself directly by using the ingress route rather than just the ingress resource. You can define custom rules, custom middleware that you want to use for specific routes. You can get as fancy as you want to. Anything that you can do with the standard Traefik server, you can do through ingress and the custom resource definitions, which opens up a lot of opportunities. One of the things that I was tempted to do is hop in and say, oh, this is great. I can actually, kind of put this stuff together and piece together my own API management solution that's all Kubernetes native to do this. And well, that's kind of true, right? There is a fairly stark difference in what you're going to be able to do with a full-fledged API manager, especially like Kong or WSO2 or Tyke, right? That really focus on those specific things, and what you're going to be able to do through Ingress and a little bit of hacking. Right? You can get by with a poor man's version, but that's probably not something you want to go to pro with. Some of the big differences that you're going to run into when you try to do that are that the interaction with your application, how your application addresses the authorization, how it interacts with, or how it leverages service discovery, how easy it is to deal with failover and versionings and release, whether it can do transformations on the actual requests, do some kind of mediation for the requests coming in. All that stuff is kind of native to your API manager solutions, and it takes a bit of work to do. In some cases, it's not possible to do with Traefik. So measure and figure out what you actually need. But for us, this has been awesome. So we're pretty happy. The last thing I'll hit on is uptime monitoring and health checks. And for that, I'm really not going to do anything super fancy here. I'm just going to point out that Traefik does have a pretty nice API. So let's start up a local instance of this again. Okay, so here we have our dashboard running. There's also an API behind this. So API v1. Oh no, it's an entry point. Every time I do this, I get the URL wrong, which gives me a good chance to point out that, by the way, there's really good documentation in here. Let's see, so operations API. Here we go. API entry points. Right, so I just didn't need the V1 in there. So you can come in here and you can query the API for almost anything you need. It'll list everything that's currently running. I want to look at, let's see, 2 points, web. And I want to look at web. I'm trying to find services. Okay, so here I can find the list of all the services that are available. I want to find out from the API what the status of my service is right now, right? And so querying for a list of all services, I'm going to get back this JSON. Each bit of JSON is going to give me some information about whether the status is enabled or not, if it's load balanced, if it's internal, if it's external. For all of the load balance services that are external, you're going to be able to get this service status object in the response. And you can use that to figure out whether or not the service is up or not. If you know the service name, you can query it directly, right? And And this is something that you can take and scrape for standard monitoring check. Right, if you want to run your own external uptime service, here's a great source of information that you get for free. This will reflect everything that Traefik is proxying. So like in those lab deployments that we showed over here when we were deploying out our training environments, we can hit the Traefik server and get information back about every single service that it's exposing. Right, so we don't have to wire up basic health checks and monitorings on those services, right? Because Traefik is giving those to us for free. So you can do that. And Traefik also has a metrics endpoint that I don't think I activated. No, I didn't. But it does have, you can start it up with metrics. So Prometheus can scrape it and you can get a lot of this information out of there as well. That's going to be time series data that you can use to, build out pretty graphs and generate dashboards and things inside of Grafana for your admins and for your own peace of mind. But that's about what I wanted to run through today, right? So Traefik, you can do a lot of stuff with it. I love using it for pretty much every situation that you would want to use an edge proxy for. Here are a handful of examples that we used. The URL to the GitHub repo is posted in this video and on the description. So you should be able to grab that and kick the tires on some of this stuff yourself. If you have any questions, feel free to throw them out there now. You can always hit me up as Dear Dooley on Twitter, or feel free to reach out. I'm Rion Dooley at datamachines.io. But with that, I'm going to say thank you and hand the mic back over.
Rion, that was super awesome. I love seeing the live code for almost the whole session. So thanks for that. And what an organized, amazing way to present this meetup. Thanks. And so now what we do is we wrap this up, and I'm going to go ahead and upload it to YouTube. And then we'll share it in our newsletter to our huge community and on social media. And then, like Rion said, you can reach him at Dear Dooley on Twitter, on the Twitters, as they say, and via email. So love that GitHub link. Thank you for everything. And as we do in our neck of the woods, we do a virtual fist bump if you're down. Boom. Okay, cool. Thanks so much. And thank you for attending today, and we'll see you around. Take care.
Thank you. Bye-bye.